Welcome to the cupola. Ready to play a little music?
Indeed. Your scenery looks a little nicer than ours. Have you got everything you need? Do you have your trusty floating guitar pick with you? Excellent. Mine is subject to gravity. Yeah, I know. Yours matches your mission patch. Gleeks, are you guys ready to do this?
Yeah!
Chris, ready to go?
Yes, Ed, I'm ready.
Okay.
Let's do this.
Let's do it.
On solid fuel wires, turn the key and light the fire. We're leaving Earth today. This rocket's burning bright. We'll soon be out of sight and orbiting in space. Push back in my seat. Look out my window, there goes home. That ball of shiny blue houses everybody anybody ever knew. So sing your song, I'm listening. Out where stars are listening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I want to get back soon. 18,000 miles an hour, fueled by science and solar power. The ocean's racing past. At 5,000 tons, 90 minutes moon to sun. A bullet can't go half this fast. Floating from my seat, look out my window, there goes home. That brilliant ball of blue is where I'm from and also where I'm going to. So sing your song, I'm listening. Out where stars are listening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I wanna get back soon. All black and white just fades to gray, where the sun rises 16 times a day. You can't make out borders from up here, just a spinning all the big tiny atmosphere. Push back in my seat, look out my window, here comes home. What once was fueled by fear now has 15 nations orbiting together here. So sing your song, I'm listening. Out where stars are listening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I wanna get back soon. Or you know why I wanna get back soon. You know why I wanna get back. soon.
Big smoke standing in the morning. Big smoke pointed at the sky. Big smoke, take away our brother. Lift him up and show us how to fly. Big smoke, louder than the thunder. Big smoke, taller than the storm. Big smoke, rise above these troubles. Lift us up and keep him safe and warm. And I don't know why we ride on the flame, 'cause sometimes we're riding blind. All I know is the future is waiting out there for us to find. Big smoke, 10,000 years of building. Big smoke, all the careful plans. Big smoke, pure imagination, lifted by a million steady hands. And I don't know why we ride on the flame, 'cause sometimes we're riding blind. All I know is the future is waiting out there for us to find. Big smoke, no one says it's easy. Big smoke, more fragile than you see. Big smoke, carry precious cargo. Show us how to live, how to dream. And big smoke, carry precious cargo. Show us how to live, how to dream.
T-minus 10, 9, 8, 7, 6, 5.
Now suppression water system activated.
15. Close and lock your visors and initiate O2 flow. 10.
Go for
One final time for the start of a sentimental journey into history.
Ignition sequence start.
All 3 engines up and burning. 2, 1, 0.
3, 4, 2, 3, 1, 0.
Space shuttle and left.
We have a liftoff.
Clears the tower.
Liftoff on Apollo 11.
Stop ignition 41.
Tower cleared.
Right at the end of Discovery, and the shuttle has cleared the tower.
Aha. How about now? You can hear me now? That's hilarious. Should be good now. I see the green bar is doing its thing. Let me know if you can hear me. Excellent. Well, hello, MX304 and Infinity GCX. Good to see you guys. Glad you're here. So I'll start over what I was just saying. Just for some context, this test is test 3 of 4. There's gonna be one more tomorrow. Testing the F-15-0 Estes rocket motor. It's a solid rocket motor, black powder, good stuff. And I'm doing this in cooperation with a friend of mine, Barnard. Oh, no problem. This is what happens when you live stream from your phone. Hold on. There we go. Okay, it should be. Hey, hello, Melanie. That's my sister, Melanie. She's somewhere in Canada. Anyway, so we're about to get going here. This is going to be a good test. Yesterday's test was fantastic. Perfect temperature data, perfect loads, as far as I can tell, and perfect acceleration data, as well as timing looked great. So, so it's looking good. I just ran through the test activation or the power-up procedure, and we're about to move into test activation. So you'll hear a couple things, but primarily you'll hear the terminal count, which starts at 420 seconds, so 7 minutes. And I'll try and keep on the mic as much as possible because it's cool for you guys to hear what's going on. Cool. All right. Well, let's get started here. Moving into procedure 0.5 test activation, step -1. So I'm gonna put the camera outside, this camera, which is my phone, and hopefully it doesn't blow up. Like, that would really suck. I'd have to go get another phone. So I'm gonna switch back to the title page or the standby page. You guys just hang out for a minute, and I'll come back when the camera's outside. So 1 moment. Okay, and I'm back. I'm standing here in the blockhouse, basically mission control for the test. And Nat, I see your comment. I'm doing great. How are you? And the dumbbells are actually not on the load cells, so they don't actually contribute at all to the load. So they don't really need to be calibrated. They're just holding the thing down. So when it fires down, test stand doesn't go up. That would be kind of a bit of a bad day. Now, everybody just chime in and let me know if you can actually hear what I'm saying. It'd be kind of awkward if you couldn't. We're about to go into test activation procedures, so just stand by one moment. Okay, so briefing. Standard fire extinguisher positions are in effect. Primary suppression is pointing toward the flame duct. Secondary suppression is ready at the corner position, and tertiary suppression is ready at HCS. DCS is go. Sensors check. Standby one. Okay, pressures are go. Temperatures. Okay, let's see. It'll be, well, looks like there's a problem with T1 and T2, so probably 5 minutes.
Okay.
Yeah, just
Like
so you know, you're on the
before
live
the
stream.
countdown?
Yeah, 5 minutes before the start of the countdown. That seems like what it is right now. So, yeah,
Right, okay.
I've got to recalibrate or check some of these sensors, but I'll let you know. Okay, so we've got an issue with the temperature. What's that?
Do you need me to do it?
Okay, and we're back. So there's an issue, as you guys can probably see on the sensors display that you have there. The casing temperature and exit temperature thermocouples are either not connected or faulted. So we're going to continue with the sensors check, and we'll have to solve that one. Pressure or voltages look good. The vibration magnitude is good. Internal temperature is running a little hot at 37 Celsius. Let me note that. But within limits. Loads. Okay, we're going to have to do a load cell recalibration or re-tear because load 0 is trending a little low at 0.38. So I'm going to move into that procedure first, and then we'll go check out the temperatures. Procedure 0.3 loads re-tear. 5 volts off. 5 volts on. Okay, HDCS reset micros. Okay, the re-tear is in process, and you're going to see me run out there and check the temperature sensor. So stand by one, everybody.
Okay, everybody, I'm back. As you probably saw out there, I tried exactly what MX304 suggested on the chat. Unplug it and plug it back in. And I don't seem to be getting any data, or at least it's all erroneous, out of T2, which is my exit temperature thermocouple. And T1 is stuck at -1. So that usually means, not usually, that always means it's unplugged. However, I just checked it and it seems like it's plugged in, so I'll definitely go double check that one. But the window's closing pretty fast because my range video recorder that you guys are seeing right now is actually just my phone, and it's about to run out of battery. So what if that happens, what we'll do is I'll recharge it up to a certain percentage and we'll just recycle and try again. The latest time that I'll attempt a firing here is 8:30 p.m. Pacific time. So I don't know what that is in Universal. You guys can figure it out. Anyway, yeah, I'm going to continue to work the T1, T2 problem. And yeah, and to quickly answer Infinity GCX's question, software-wise, it's all custom, and hardware-wise, it's all custom. To a certain degree. The hardware is a lot of Adafruit stuff, and pretty much a lot of Arduino stuff, pushing it to sort of the limits of what it can actually do. So anyway, you can tweet me if you have any additional questions. So anyway, stand by. I'm gonna stop the video and we'll go back to standby. So you guys just hang in there, and because it probably is pretty boring to just watch me go twiddle on a test stand. So I'm gonna switch to standby, and or maybe the title screen, and you guys just hang in there and I'll be right back. Well, as you guys might have seen there, we got the temperatures back. So both thermocouples are active. It was literally just an unplug it and plug it back in. Anyway, so we're going to proceed back into step 1 of 0.5, which is test activation, and I'll get back to you. Okay, so sensors check. Let's go back to the top here. Pressures are go, temperatures are go, voltages are go, vibrations are go, the internal electronics temperatures go at 37, holding steady. The loads, let's see here. Okay, loads are looking good. We've got a slight bias on Z3, but it's within limits at 0.14-ish. So all sensors are go, moving into HDCS define test. Okay, so I need a vote on this one. I've been trying different ignition times, and I've had success now with 0.5 seconds. I've had success with 0.25 seconds. This is the duration that the voltage is applied to the electric igniters. And I think I'm going to try 0.1. So if you guys have any suggestions against that, maybe go longer, go shorter, you let me know. It's kind of just, I've just been sort of cutting it in half every time. But let me know what you guys think. I'll wait for some comments. Alright, I'm not seeing any suggestions, so I think we'll just go with 0.1. Ignition duration of 0.1. Okay, matrix definition upload has begun. Okay, solid matrix upload. Moving along to step 3. Test definition is as follows. At T-minus 420 seconds, the count begins. At T plus 0 seconds, the igniter is activated, and T plus 0.1 seconds, igniter is deactivated. Okay, initiating the range video uplink. Yeah, I see you guys still have the splash screen. My phone's charging right now. I'm going to let it go to the last second so we can definitely get it on the good camera. So we're in step 4 right now, initiating range video uplink. And the range video uplink is active. I'm going to show you guys that because that's a little cooler than the splash screen. There we go. So that's the GoPro link. It's pretty horrible in terms of delay, but it does verify for me that the GoPro is active. Yeah, Nat, so I tried 0.5 on the first test, then tried 0.25 on the second test, and now I'm trying 0.1. Anyway, moving on to step 5, we'll initiate range video recording. Range video recording is active. Brief test safety, okay. This is the point where I call down my GC, so stand by. So stand by, everyone. We're just doing the fire briefing, and we'll get going here in just a sec. Announcement. Okay, so in the event of a brush fire, activate HACS fire suppression. Operator has 5 seconds to decide to call LAFD or proceed with his own methods. To indicate a negligible fire condition, announce null fire suppression. To indicate a controllable fire condition, announce suppress, suppress, suppress. And to indicate a uncontrollable fire condition, announce 911, 911, 911. Prompting the GC, that's you, to call LAFD with no delay. Okay, count begins on my mark. Stand by. 3, 2, 1, mark. Okay, so we've had a count hold at 3:39 seconds. We're going to recycle. Looks like the cause was micro 1 indicated a failure by micro 2. Proceeding into step or procedure 1.1. The cause could be loss of interlink integrity, arm mode disagree, or count mode disagree. So we're going to recycle and redo the test upload. Proceeding to 0.5 step 2. Okay, matrix upload completed successfully. What happened there, everybody, was one of the microcontrollers thought it was dead, but it was really just a sensing problem. I've just cleared that up, and so we're going to start the count. We'll proceed from where we left off at T-minus 330 seconds. Beginning the count on my mark. Stand by. 3, 2, 1, mark. By the way, T-minus 5 minutes. T-minus 4 minutes. T-minus 3 minutes. T-minus 2 minutes. HACS RSSI is nominal at negative 980. Okay, T-minus 90 seconds, we're armed. T-minus 60 seconds, plots are verified off. T-minus 40 seconds, log is on. T-minus 30 seconds, fire suppression on. T-minus 20 seconds, auto idle. Okay, we had a halt, no arm condition. Fire suppression off. Count is verified as halt. We'll set T-minus 90 seconds. Okay, so standby for procedure 1.0. We've reset the count at T-minus 90 seconds. Mode 0 cause was, standby. No arm condition. This indicates the arm was not present within the ADCS terminal count. To halt alarms, set count greater than 20 seconds. We've done that. So that's the cause. We're going to recycle. It was probably a HACS link issue, so we'll try and get an RSSI of 970 here, and then we'll proceed with the count. Okay, so it's the RSSI is steady at 960 to 970. We're going to go back into test activation procedure. Step 7 will be at T-minus 90, and we'll arm. So stand by to pick up the count. 3, 2, 1, mark. And we are armed via HACS. Okay, T-minus 60, we're at plots off, and that's confirmed. T-minus 50. Okay, approaching T-minus 40. The log is on. T-minus 30, fire suppression on. Good delay. Okay, T-minus 20, the auto idle is active. Alright, here we go. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, shutdown. Fire suppression's on. Looks like we are null fire suppression. Yeah, I just saw the video there. Null fire suppression. Looks good. T plus 15, 16 seconds. We'll go ahead and stop. We've had a automatic stop because the temperature got to 250 there on the exit temps, above limits. Okay, continuing in T plus 60 seconds here, we will secure the data. Okay, HDCS log is, we'll keep the HDCS log on and everything on there. Do you want to go ahead and check?
Oh, sure.
Yeah, I'm just going to keep the fire suppression going.
Wait, you're gonna what?
I'm going to keep the hose going. I'll keep the water going. Everything else is off. Okay. Range video recording, stop. Look good? Excellent. Thank you for your help. Good to go.
What?
Good to go. Thanks for your help.
Oh, yeah.
All right.
You're saying that for the microphone?
For everybody. That looked great, though. Wow. That was awesome. I was watching the exit temperature, and it went up. It was like literally a half a second after ignition, it was at 250 degrees Celsius. It's just like,
wow.
Well, it went red.
It should be, right?
Yeah. It's about what it should be, yeah. Yeah, it's not like the bad thing. That was like expected. But
that's
anyway.
where the thing launches, right?
At 250. Yeah. That's like the exhaust, like the heat basically coming out. Yeah, it was like 250 C. It's very hot. All right, I think we got enough data now. We're back at 7. I'll keep it going until the exit temperature is ambient. So anyway, that's about it, everybody, on the webcast. Hope that was entertaining. And the test is complete. The data is about to be secured, and we're proceeding to debrief. So stay tuned. Tomorrow will be another test about the same time. So just go to my Twitter and enjoy.